Hi, this is third and last part of the workshop about automating desktop UI testing in Rapise. I am Alexey Grinevich from Inflectra Rapise team. If you have any questions during or after this session, please use the chat window for this workshop. In this last part, we will talk about command line interface, API testing as a part of desktop testing, and finally, about launching and closing an application. Command line, file access and API access may be considered as input and output methods. These are the ways we interact with the applications. These are the ways we force application to do something and we read some information from it. And here is an example of how command line may be useful. We are going to open something in the WordPad application. I have no WordPad available on the screen yet, so I'm going to do a bit tricky way. Instead of launching it using the start menu, I'm going to use global do launch operation and type wordpad.exe. Usually it's available in the path, so simply naming it by the executable name is enough. And simply playing that. You see that WordPad shows up on the screen. Suppose that now I want to open some RTF file in it. So I'm doing record. Since I didn't do recording in this project yet, and it's first recording, it asks me to find an application to record for. It's a document. It's a WordPad with untitled document. Now, my goal is to open the file, so I click on File. Once more, click Open. Click on File Name. So by default it opens in the Documents folder, so I may simply type the document name and click Open. So it shows up, and my interaction here takes 1, 2, 3, 4, 5 operations. So this is one way of opening the document in the WordPad. So I have these 5 operations, I have a number of objects here, and it takes some place on the screen. There is an alternative way, as I said before, so I may do it easier and simpler. So I'm removing these steps, I'm removing all the objects from here, I'm not going to use them. I just want to pass the full path to this document to the launch operation. So properties, for the file, get folder name and append them to the command line, and then append the file name itself, basic document RTF. When editing a cell in Rapise, if I want to edit a part of the cell, I need to press F2, and then I may use cursor keys here inside. So I'm appending basic document RTF here. So now if I just play it, the document shows up. So instead of 5 lines, I have one liner in RWL that does the same. It's quite common for applications to provide some interface. For older applications, the interface type is likely to be COM or ActiveX. For example, all members of Microsoft Office family provide COM ActiveX interface, and Rapise contains examples of working with Microsoft Access, Microsoft Excel, and Microsoft Word. You may open these examples from the start page. Today, it's more likely to contain some sort of REST interface or TCP interface. And now we will look at application that contains this type of the interface. In this example, we're going to use API to automate an application. We already seen this application in the previous session, and we found that we have no capabilities to read contents that are displayed on this screen. So we may somehow send text to it because we may do send keys and it mostly accepts keyboard input. But we cannot read the output from our operation and check the results of our actions. Long story short, this type of terminal emulator that connects to IBM i7.4, which is former S400 system. So the terminal that connects to this remote mainframe has its own API to interact with it. And it has a help system, and here I found some information about it. So with some command line key passed in, it enables a number of operations that I may use. So let me do that and let me see how it works. I have this emulator executed with this batch command. That is passing the port number for API with the KHTTPD. This is a built-in feature for this terminal emulator. So since it's running in this mode already, I may try to access this API. So I'm going to localhost, then port number I specified in my batch file, and then entry point. Let's see what happens. It shows me something. And this something contains a REST section where I may do some interactions and see, for example, status. Also, it contains the interact session, and here I may try the same commands. For example, I may set a title. This is one of available commands for this terminal. Hi there. Sending it there, and let's look at the title of the window. It's now hi there, so I may do something. The question is how to read information from the screen, and there is a command for that: print text string. If I send it, in the output what I get is the text representation from this emulator. So now we need to use the features of Rapise to access this API and to use this in our test. Here is Rapise with empty test, and to access the API I have the simplest way is to use web service, and REST web service wrapper should do what I need. I know the URL, and URL for web services should probably be one with the REST endpoint. I think this one. And I can change the query to the one I used before in the interactive session, print text string. Hit enter, and you see I have plain output from the terminal screen. So I may read what it tells to me. Okay, let me use this as URL for web service call. Call it get screen text, for example, and I may just use to send it. And you see, Rapise receives the contents of the screen by using this API call. So I'm just doing record of this action and hitting create script. It generates JavaScript code to call this operation from JavaScript, and I may also find it here. So this is the way how to execute this specific operation. So I'm going to read the results of this operation. The API call uses JavaScript and my test will be using RWL. So I'm going to write this piece that were generated into JavaScript code. I'm selecting the generated lines and choosing extract user scenario, and we'll call it get screen text. Okay, it adds the function to implement this scenario and it adds the call to this function to the main file. I don't want to call it here, I will use it from RWL, so my test function stays to be one-liner, and here the last step I'm going to do is to read the results of the REST call after doing the execution. I may do it using this object and then get response body text. It would be the return from this operation. Now I'm going to just call this method from here. I'm using functions object, it's global object to access user-defined functions, and get screen text is my function, and I'm just going to print this result to the report. Tester message, and here I'm going to use variable last result, which would contain result from previous operation, which is get screen text. Okay, I'm playing this script now. And you see the contents of the screen output are here. And this is the first step to start working with this application. We know how to get contents of the screen. We may use other API entry points. There are plenty of them. We may even read such things as color of specific character, or we may send some specific character combinations using this API. So it adds for us many additional ways to interact with this application. But the key and first step that we need to do is to find this API, learn about it, and know how to interact with it. So this is what we just demonstrated. Since there are many possible technologies and many ways of launching and closing an application on the desktop, it is worth to consider this topic separately. Now let's talk about launching and closing an application when executing the test. Here we have calculator. I'm going to record very trivial test. It's just clicking on the button and that's it. One step. My test would pass if I just play it while calculator is on the screen. But if I close it and play it again, nothing would happen. It's waiting for something. Actually, it's trying to find this one button on the screen for some time, and finally is saying that object is not found, so no calculator. So my goal is to launch calculator before playing this test. So I'm adding an operation, global, do launch, and parameter is the path to this calculator. I have a shortcut, so I may take the path from here. I may also close these windows and put it into the parameter value. So it's command line that will be executed. So now if I play this test, it would launch the same calculator. But if I play it again, it's launching calculator again. This is not an effect that I wanted. So there are two ways on how to deal here. First of all, of course, I want to close my calculator if my test passed. So I may simply record one more step. That would be a click on the close button. So this is one possible way of ending this test. But what will happen is if I have one calculator on the screen, it will create second one and will close second one whilst this one will keep running. If my test is changed, if I do, for example, some invalid assertion, I'm asserting two different values, TBD and TBD1. So it would fail here and stop execution. It would create second instance of calculator, leave it running as is, and won't close it in the end because execution stops here. So when running it for the second time, that would be useful if I just attach to the same calculator and I don't create new instances. So in this approach, it's useful to have one calculator running, because if test failed, it's good to see what has happened to application and look at it. Try it, maybe try to find some object. On the other hand, we don't want to produce more and more calc applications on the screen for each run. So useful workaround is to use additional parameters for the do launch. I click on the do launch and click on the params, and you may see that additional parameters shows up. First is the command line, then working directory. That's not relevant for calculator, it may work with any working directory. Then attach if exists, and that's good option. It's boolean and I want to set it to true. So if it's found on the screen, keep working with this application, don't create new one. And if it's found, we need to know the window on how to find it and what to find. So the window name is the one that's recorded here. So if object with this window name is found on the screen, then keep using this one. Let me close one calculator and leave just one available and play this again. And you see, no second instance created. Now I may work with my test, keeping one instance of application running, and finally I may fix it. In my case, fix is to remove this assertion or make it equal, but removing is fine. So remove this assertion and hit play, and it works. Application gets removed in the end. Alternative way of closing the application is to use keyboard shortcut, and I'm using global object that has do send keys, and I want to send Alt F4 that closes current application. If I don't know how to do this, I could use the help system about do send keys, and it links to the page with information about available key combinations, how to send each specific key combination to the application. It contains a table and combination for each of them. In my case, it's Alt key and F4. If 4 is F4 in uppercase and curly braces, and Alt key is %sign. So I'm just going to use it here. I'm commenting out this command and playing. This was the second way of closing the application, and since we launched it using global do launch, we may use another global method for closing it. So I commented both previous way, and I'm using global do kill by. So I could kill it by name, which is calculator.exe, or I may kill it by PID, process ID, and in the case I pass nothing, you see by default it doesn't have parameters, it would use the PID of most recently created process, the process lately created by Rapise. Now I'm running the same test again, and you see it gets closed. So there are 3 different ways of closing an application. There are different alternatives of running the application, and that's good to know because these may be useful for you. Now let's look how launch and close were done in the available examples. Here we have start page, and first we open RWL Calc KDT example. Here we may see the place where it launching the calculator. It's here, and it's using the same method as we just used. It's using global do launch, it's trying to attach to existing instance if any, and it's attaching to window calculator, exactly the same way. Finally, in the end and after the loop, it's doing global do kill by PID and passing 0. It's equivalent of passing nothing, and it means close whatever we launched or attached to in the beginning. The second example, RWL Calc with JS. And while its RWL part is similar, you may see it doesn't contain any launch or close command. But it is still doing launch and close. Here is how it works. Rapise has 2 predefined entry points that you may define. It's testing it and test finish. These are JavaScript functions. Testing it is something that will be executed before any other test logic. Test finish will be done in the very end after all test steps are done. And even if there were a failure, it would execute test finish. That's why in the test init we do global do launch, we don't try to attach to a calculator, we are sure we will create a new instance. Because in the end we will have test finish executed in any case, so it will certainly kill the calculator. So this is another way of doing the same. Now, there are more sophisticated examples doing launch and close. We may find such examples on the Rapise GitHub. So I'm typing Inflectra GitHub in the omnibar to search for it. The first result leads to GitHub section from Inflectra, and here we have plenty of frameworks, sample tests, different snippets, and power pack with short pieces of logic or code. Now I'm interested in Nef. This is a framework for dynamic snap, and I may download it from here using this button, download zip. I already did this, I have it downloaded and unpacked, and it's available here in this folder. So this is dynamic snap framework. I'm opening it with Rapise, and I'm going to look on how it implemented the launch of the application. I have this framework open, and you see that in the beginning of the test it's doing the step nav launch. This nav launch is a function that I may find here in the functions section of the object tree. I'm expanding the user functions, and there is a nav launch. And you may see that it is implemented and it's not something trivial. And for desktop application, it's again a common situation, because nav may have different flavors, and for different versions it has different paths where I may find it, and this function deals with all these situations, and finally it makes sure that proper version of nav is found and executed. So it's example of real life application and launching of it, taking into account all the difficulties that such launch may have. I'm not going to execute this framework or any test from it. I may execute just this function to show that it's capable to launch the nav. Launching it. Splash screen shows up, and here is the application. We at Inflectra deal with hundreds of customer applications during trainings, troubleshooting sessions, or support. And here is the picture that we may draw on what to expect from the application from the automation point of view. Green here represents applications that are very well supported. And this is sort of 20 to 30% of all applications. These are major applications, well known or well designed, with all APIs available that we may automate properly. The red sector of this pie chart represents applications that are total black box. Due to some reasons, developers decided to close APIs, or they use some really rare technology that has no APIs or not proper support or too old to support. And in these cases, we are very limited on what we may do. But the majority of all applications we see are in so-called so-so stage. So they have some APIs, they are partially automatable, but there are some problems that we need to overcome. That is why it is good to know the things that we described today. So we should know that there are alternative ways of doing same things, and depending on current situation, you may have to choose one approach or another on doing the same thing. This contrasts to experience of manual testers, because usually when we do something as a user with some application, normally if we do the same thing for several times, we are doing it exactly the same way. And this way usually involves our eyes and, say, mouse or keyboard. With automation we have more ways, and we should be aware of them, because it differs automation from manual testing. And during these sessions, regardless of the aspect of automation that we were considering, we saw that there is always more than one method of doing the same. And it's always good to find a place where to see good example to use in your project. Thank you for joining.